Good afternoon, students. In last class, I was telling about electrostatics of a conductor. In that, I left one of the properties of a conductor, that is electrostatic shielding. Fifth one is the electrostatic shielding. So first, I want to tell about that one, electrostatic shielding. Yes, what do you mean by electrostatic shielding? Means electrostatic shielding is the special method. It is a special method which is used for protecting devices, especially practical appliances, practical instruments, so sensitive instruments. We can call them as sensitive instruments, or certain space, certain region of space from the effect of external electric field. So what I am telling is, I am telling about electrostatic shielding. Electrostatic shielding is the method. It is a method which is used for protecting a region of space or several instruments from the effect of external electric field. So see, by using the electrostatic shielding method, it is possible to protect the devices from the from the heavy electric fields or from the huge amount of electric fields. See, during the time of lightning, it's better to move inside of a house, or it's better to stand inside of a vehicle instead of standing in an open ground. So here, a house, vehicle, they acts as a shield for protecting us from the effect of lightning charges. Here the lightning is external electric field. ಸೊ ಸಿಡಿಲ್ ಬರ್ತಾ ಇದೆ ಅಂದ್ರೆ ನಾವೇನು ಮಾಡಬೇಕು, ಮನೆ ಒಳಗಡೆ ಆದ್ರೂ ಇರಬೇಕು ಅಥವಾ ಒಂದು ವೆಹಿಕಲ್ ಒಳಗಡೆ ಆದ್ರೂ ಒಂದು ವಾಹನದ ಒಳಗಡೆ ಆದ್ರೂ ಇರಬೇಕು. ನಾವು ಹೊರಗಡೆ ಇದ್ರೂ ಅಂದ್ರೆ ಡೈರೆಕ್ಟ್ ಆಗಿ ನಮ್ಮ ಮೇಲೆ ಅಟ್ಯಾಕ್ ಆಗುತ್ತೆ ಸಿಡಿಲಿಂದ. ಅದ್ರದ್ದು ರೀಸನ್ಸ್ ಏನಿದೆ ಅಂದ್ರೆ, ಸೊ ದೇರ್ ಟು ಅವಾಯ್ಡ್ ದ ಎಫೆಕ್ಟ್ ಆಫ್ ಎಕ್ಸ್ಟರ್ನಲ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್, we are selecting one particular device called home or vehicle. So like that only, for several instruments, a method called electrostatic shielding is applied just to protect them from the avoid the spoiling of instruments from heavy or a huge amount of electric field which is applied to the device or applied to the instruments, right? What is an electrostatic shielding? Electrostatic shielding means it is a method or a technique for which protects certain regions, certain devices, certain instruments from the effect of external electric field, right? So see, now come to this point. Here is the concept: potential energy of a dipole in an external electric field. Now I am telling you about the potential energy of an electric dipole which is placed in an external electric field. So here, see here, this diagram represents these arrow marks represents uniform electric field. These arrow marks are giving uniform electric field. So arrow marks, constant value of electric field, it is represented by a set of arrow marks here. And I am taking a dipole here. This is the dipole. You can see here, this is the dipole, as it is consisting of remember, what do you mean by electric dipole? Electric dipole means a system of two charges which are equal and opposite in nature and separated by a small distance. So here also this diagram represents an electric dipole, as it is consisting of Q1 equals to Q and Q2 equals to minus Q, and it is separated by a distance 2L. So see here, what I am taking here, here I am showing an electric dipole. This is the electric dipole which is separated by a distance 2L and which is consisting of the charges Q and minus Q. So first, what I can say, what you should do is here, consider a dipole consisting of two charges. First charge is Q and the second charge is minus Q, right? And remember, this electric dipole is placed in a uniform electric field. This dipole is placed in a uniform electric field, Yes, and you know that whenever a dipole is placed in a uniform electric field, that dipole experiences zero force. Dipole means two equal and opposite charges. So positive charge experience a force F equals to QE. Negative charge minus Q experience a force F equals to minus QE. So the total charge becomes zero. The total force acting on the dipole because of this uniform electric field becomes zero, because its two ends they are experiencing equal and opposite forces. This one positive force and this one negative force. So positive force and negative force cancels each other, right? So here see the dipole is experiencing a zero force, and the next one the dipole is experiencing a torque. So whenever a dipole is placed in a uniform electric field, the dipole experiences zero force and a torque acts on the dipole. Torque. That torque is given by torque which is acting on the dipole because of this field is given by tau equals to P sin theta. I am taking this one as equation number 1, where P is electric dipole moment, E is electric field, theta is the angle which is given by the dipole during its rotation. Here torque, what it does, torque rotates the dipole in the given electric field. Here the dipole is rotated by this electric field through an angle theta. So this torque rotates the dipole. So now you imagine we are applying an external torque, an external torque on this dipole such that torque is able to neutralize the effect of internal torque. That torque cancels or it neutralizes the torque acting on the dipole, and also that applied torque is able to rotate the dipole in between two angles. One is theta 1 equals to pi by 2 and theta 2 equals to theta. So ಇಲ್ಲಿ ನಾನು ಏನು ಹೇಳ್ತಾ ಇದ್ದೀನಿ, ಈಗ ಏನು ಮಾಡೋಣ, ಒಂದು ಇಮ್ಯಾಜಿನೇಷನ್ ಮಾಡ್ಕೊಳ್ರಿ. ನಾವು ಒಂದು ಹೊರಗಡೆಯಿಂದ ಒಂದು ಟಾರ್ಕ್ ಅಂದ್ರೆ ನೀವು ರೊಟೇಟಿಂಗ್ ಫೋರ್ಸ್, ಟಾರ್ಕ್ ಮೀನ್ಸ್ ಫೋರ್ಸ್, ಟರ್ನಿಂಗ್ ಎಫೆಕ್ಟ್ produced by a force. ಇದನ್ನು ನಾವು ಟಾರ್ಕ್ ಅಂತ ಕರಿತೀವಿ. So now if you are applying a torque on this dipole, that torque must neutralize the internal torque. ಈ ಮೊದಲೇ ಇರುವಂತ ಈ ಒಂದು ಟಾರ್ಕ್ ನ ಅದು ಕ್ಯಾನ್ಸಲ್ ಮಾಡಬಹುದು, ಝೀರೋ ಮಾಡಬಹುದು, ನ್ಯೂಟ್ರಲೈಸ್ ಝೀರೋ ಮಾಡಬಹುದು. And one more thing, this applied torque must rotate the dipole through two angles. Theta 1 equals to pi by 2 and theta 2 equals to theta. So in that case now it means external torque is doing a work. External torque is rotate ಮಾಡ್ತಾ ಇದೆ ಅಂದ್ರೆ ಅದು ಕೆಲಸ ಮಾಡ್ತಾ ಇದೆ ಅಂತ ಅರ್ಥ. That work, external torque is doing a work. That external torque, it is doing a work. That work done by the external torque is given by W equals to integration of theta 1 to theta 2 external torque, tau external into d theta. This d theta means two angles pi by 2 to theta. Rotation ಆಗೋದು, ಈ angle ಅಲ್ಲಿ rotation ಆಗುತ್ತೆ. So here work done is W equals to integration of theta 1 to theta 2 tau external into d theta, right? W equals to integration of theta 1 is pi by 2, theta 2 is theta, and tau external means it is equation number 1. Tau external torque is also similar to expression of torque. Tau equals to P sin theta. ನಾವು ಅದನ್ನೇ ಇಲ್ಲಿ ತಗೋಬಹುದು, ಈ ಮನ್ಸ ಬೇರೆ ಬರಲ್ಲ. Tau external is P sin theta into d theta. P sin theta into d theta. Here the angles are theta 1 equals to pi by 2, theta 2 equals to theta. So W equals to P into integration of pi by 2 to theta into P. I am taking P outside. P is electric dipole moment, E is electric field. So P into sin theta into d theta. So W equals to P into integration of sin theta is minus cos theta. Yes, what is the value of integration of sin theta? It is minus cos theta. Integration of sin theta is minus cos theta. So here pi by 2 theta. So first I am taking theta into consideration. So minus cos theta minus of minus lower limit. So when you apply the limits, when you are taking the limits into the bracket, first upper limit should be taken, and when you are taking the lower limit, a negative sign should be given in between the two terms. So minus cos theta minus of this minus cos pi by 2, minus cos pi by 2 minus cos theta minus of minus plus cos pi by 2. Cos pi by 2, cos 90 degree, cos 90 degree is 0. You know the value of cos 90 is 0. So W equals to P into minus cos theta plus 0. So W equals to P into minus cos theta. W equals to minus P cos theta. Right? And remember, this work done by the external torque is equal to potential energy of a dipole in external field. What you are deriving, that is nothing but work done by the external torque. Here work done by the external torque is minus Pe cos theta. This work done by the external torque is itself the value for potential energy of a dipole in external field. Right? Therefore, what is the expression for electric potential energy of a dipole placed in an external field? U equals to minus Pe cos theta. U equals to minus Pe cos theta. So once you go through the derivation, you will definitely understand. Here it's very simple. First I consider a dipole placed in an electric field, and the nature of electric field is a uniform electric field. Right? Whenever dipole is placed in a uniform electric field, it experiences force, zero force equal to 0, and torque. So torque, that torque is given by phi equals to P sin theta, equation number 1. And this torque rotates the dipole in this electric field. Suppose an external torque is applied such that it cancels the torque toe and rotates the dipole in the plane of the surface between theta 1 equals to pi by 2 and theta 2 equals to theta. If you are applying an external torque which is able to cancel the effect of internal torque which is acting on the dipole because of this electric field, and the external torque also rotates the dipole in between two angles, theta 1 equals to pi by 2, theta 2 equals to theta. Then work done by the dipole is, here work done by the dipole means here external torque is rotating the dipole, means it is doing some amount of work. That work done is itself potential energy of the dipole. So work done, so therefore we are calculating work done by the dipole. W equals to integration of theta 1 to theta 2 to external d theta. W equals to integration of theta 1 is pi by 2, theta 2 is theta. P sin theta into d theta. So W equals to P, I am taking P outside. Integration of sin theta is minus cos theta. Apply the limits theta and pi by 2. So you will get cos minus cos theta minus of minus plus cos pi by 2 is 0. Then W equals to minus P cos theta. And this work done is stored as potential energy of the dipole. Right? Therefore, what is the expression for potential energy of the dipole? U equals to minus P cos theta. Okay? Have a nice day.